What's happening, y'all? Pastic here again. Hope everybody's doing all right. We got section 1.3, exploring real numbers. The objective for this section is to identify and differentiate between number sets as well as understand the magnitude of numbers. Example, numero uno says name the sets of numbers to which each number belongs. In order to do that, you're going to have to know the different types of number sets. So I'm going to write them over here. We've got real numbers. It's basically any number. Real numbers are literally any number you could possibly think of, unless you know about I, which is the imaginary number, and therefore not real. We have whole numbers that look like 0, 1, 2, 3, and so forth. 4, 5, 6, 7, 8, 9, 10. No fractions, no decimals, no negatives in the whole numbers. You've got integers. Integers. Integers are whole numbers and their opposites. So you've got -3, -2, -1, 0, 1, 2, 3, and so forth. And you can also go in the other direction, -4, -5, -6, and so forth. Then you've got rational numbers. I'm all messed up. Oh boy. Then you've got rational numbers. I'm going to figure this out, y'all. Bear with me. Sorry about that. You've got rational numbers. Which are any or all numbers or any number that can be written as a fraction. As a fraction. And then you've got irrational. Irrational numbers are numbers that cannot be written as fractions. Cool. So, -13. Pretty much these are all going to be real numbers. So for A, we're going to put real. What else is it? Well, it's a negative number. So that rules out whole numbers. Is it an integer? Oh yeah, because it's a opposite of a whole number. What about rational? Can -13 be written as a fraction? -13/1 is a fraction. So yes, so it is rational. And that's all she wrote for part A. Part B. 3.28. That rules out rational. Actually, no, it doesn't. 3.28 can be written as a fraction. It can be written as 328/100. So you can write that as a fraction. So that is rational. It is real. They're all real, again. Is it a whole number? No, because it's a decimal. Is it an integer? No, because it's a decimal. Is it irrational? No, because it's rational. Cool. Part C. 13/25. So we got a fraction here. So automatically fractions become rational. Is it real? Oh yeah. They're all real. Is it irrational? No, because it's rational. Is it an integer? No, because it's a fraction. And is it a whole number? No, because it's a fraction. Cool beans. And last one, which I'm going to hopefully fit on the other side without messing this up. 42. is real, because it's a number. It is whole, because it's counting up from 0. It is a whole number, not a fraction, not a decimal, correct? So it is rational. It is I think I just screwed that up. So it is whole, I meant to say. It is also rational because it can be written as a fraction. 42 over 1 is a fraction. And if it's rational and it's whole, if it's whole period, it's probably going to be, or it is going to be, an integer. Integers include whole numbers. So there you have it. Those are some examples of the different types of number sets. And my thing's over here now, so hopefully it works. Perfect. This example is saying which set of numbers is most reasonable for each situation. So we got to think, okay, outdoor temperatures. Start asking yourself, outdoor temperatures could be what? Can they be positive? Sure. 10 degrees, 100 degrees? Absolutely. Can they be negative? Well, it's less likely, but yes, I could have a negative 10 degrees, negative 20 degrees. So for sure, we could think of real numbers as a possibility for outdoors. What about fractions? Can they be fractions? Yes. Can they be decimals? Well, yeah, they can be, because you could have 10.2 degrees. So really, outdoor temperatures can be basically any type of number you can think of. So I think real numbers is the best fit for outdoor temperatures. What about the number of beans in a bag? Well, if I'm looking at beans in a bag, which I don't know why you would do that, but if I was, I would probably be able to count how many beans were in that bag, unless there were just a ridiculous number of beans in the bag, but I don't even know who keeps beans in the bag anyway. But anyway, beans in a bag, you could be able to count them, so you got to start asking yourself, does whole numbers make sense? 0, 1, 2, 3, 4, 5. I think it does. Does real numbers make sense? Well, no, because real numbers include decimals and negatives, and I'm not going to find -4 beans in a bag. So that also rules out integers, because the number of beans in the bag will not be negative. So I'm thinking, number of beans in the bag, I can count them up. They're all going to be positives. I'm not going to count up half beans. I'm not going to count up decimals of beans. So whole numbers makes the most sense here. Some of these you could probably have a discussion about which one is more reasonable, but these are pretty good answers to start with. And if we disagree, we can always talk about it. Determine whether the statement is true or false. If it is false, give a counterexample. All negative numbers are integers. So can I think of a negative number that is not an integer? The answer to me is yes. A negative number that's not an integer. So what about -4.5? -4.5 is negative. So that's checking off the first part. But it is not an integer. So what I've just found is called a counterexample. It's a piece of evidence that points in the other direction, that proves the statement to be potentially false. So what is my counterexample? My counterexample is going to make this first part true. So for -4.5, that's horrible. Let me fix that. -4.5 is a negative number. What I'm trying to do here is show that this part's true and this part's false with the number that I've chosen. But it is not an integer. This whole thing that I've written is my counterexample because it's a piece of evidence that shows otherwise, that proves the statement is not true. -4.5 is a negative number, but it is not an integer. All right, we want to write these three fractions in order from least to greatest. So in order to do that, we're going to need common denominators. So, -3/4. We're going to change that into some other fraction. Negative 7/12. We're going to change that into some fraction. Negative 5/8. We're going to change that into some other fraction. 4, 12, and 8. We want to find a common denominator. So the easiest way for me is to say, all right, does the smallest number go into the other numbers? So does 4, for a common denominator, does that go into 8? Is 8 divisible by 4? The answer is yes. So far we're in good shape. What about 12? Yes. Okay, cool. 4 goes into 8 and 12, but does 8 go into 12? No. So what I do is I take the biggest denominator, which is 12, and I start listing multiples of it. 12, 24. I start checking to see, is 24 now going to be divisible by 4, 12, and 8? 24 divided by 4 is 6. 24 divided by 12 is 2. 24 divided by 8 is 3. So 24 is going to work as a common denominator. How do I get from 4 to 24? I have to multiply by 6. So top times 6 as well is negative 18. How do I get from 12 to 24? I have to multiply by 2. Negative 7 times 2 is negative 14. And 8 times 3 is 24. So negative 5 times 3 is negative 15. Now that I have common denominators, I have 3 comparable fractions. And I need to order from least to greatest. So least is going to be whichever one is the most negative. This one is the most negative, meaning it's farthest away from 0 on the negative side. So that's going to be our smallest. Then I want the middle one. Well, which one's the second most negative or the second smallest? That's going to be negative 15 over 24 because I'm looking at a number line. We're going to have negative 18 here, negative 15 here, negative 14 here. Forgive my spacing, but that's the general idea. So negative 15 over 24 is in the middle, negative 5/8. And then the biggest is negative 7/12. Cool. Find each absolute value. Absolute value is distance from 0. So I'm asking myself, in this case right here for letter A, how far is negative 2.5 from 0? It is 2.5 units away from 0. How far is 7 from 0? It is 7 units from 0. Kind of a quick thing, when you're taking the absolute value of the number, your answer to that is always going to be a positive number because you're looking for how far is it from 0. The only time where the absolute value wouldn't be positive would be if you're taking the absolute value of 0, most likely. Or if you put on some other stuff, but we're not there just yet. All right, y'all. Thanks for joining me on 1.3. I hope you learned something, and I will talk to you next.